Have you ever just stopped and wondered how our bodies do what they do? I mean, a skeleton is a rigid frame, right? So how can it pull off a graceful dance or a powerful leap? Well, today, we're going to dive into the incredible engineering inside all of us that makes it happen, our joints.
Seriously, think about that for a second. We've got this solid, bony framework that gives us our shape. But at the same time, we can run, jump, type, you name it. So how can something so solid be so incredibly flexible? It really sounds like it shouldn't be possible.
Well, the answer to that puzzle is joints. They are the brilliant solution. You see, a joint is just the connection point between our bones. It's this ingenious mechanism that gives our otherwise rigid skeleton the amazing gift of movement.
Okay, so to really get how these connections work, it helps to have a couple of blueprints. Experts basically look at joints in two main ways, by what they're made of and by what they can do. So you can think of it like this. The structural classification is all about the building materials, what physical stuff is actually connecting the bones. But the functional classification, that's all about performance. How much does it move, and in what way? Let's start with that first blueprint, the structure. And we're going to begin with the joints that aren't really about big dramatic movements. These are the ones all about providing a rock-solid foundation. They are truly the unsung heroes of our skeleton.
Within this structural blueprint, there are three main types. We're going to start with the most rigid, the ones built purely for stability, and then we'll work our way up to the ones built for motion. So, first up, we have fibrous joints. You can think of these as the body's superglue. They're fixed, they're immovable, and they're designed for one main purpose, to create super strong protective structures. And this is the perfect example of their job. Fibrous joints are where bones are literally fused tight together, which, no surprise, is why they're also called fixed joints. Your skull is the best example. It's not just one big bone. It's made of several plates that are fused together by these fibrous joints to create a helmet for your brain. No movement needed, just pure, raw strength. Next up, let's look at cartilaginous joints. And just like the name says, these joints use tough, flexible cartilage to connect the bones. This allows for just a little bit of give, and they act as fantastic shock absorbers, like the ones between our vertebrae. These are what we call partly movable joints. And here's a pretty fascinating little detail. Some of these cartilage joints are actually temporary. In kids, they're what allow bones to grow, like the growth plates in our arms and legs. And then after puberty, they fuse into solid bone. Pretty cool, right? All right, we've covered the stabilizers, the support crew. Now let's get to the main event. Let's talk about the joints that are the true stars of the movement show. These are the ones that let our bodies perform all those incredible actions we do every day. And these are the synovial joints. They are by far the most common type in our bodies, and they're responsible for pretty much everything we think of as movement, from walking and running to the tiny little movements of typing on a keyboard. They're designed to move super smoothly, all thanks to a special lubricating liquid called synovial fluid that cuts down on friction. Okay, now this is where that second blueprint, the functional one, really comes into play. Because synovial joints are all about moving. They get broken down into 6 different types, based on the kind of motion they allow. So let's do a quick tour of each one. First is the ball-and-socket joint, and the name says it all. Picture one bone ending in a ball that fits perfectly into the hollow socket of another. This design gives you a huge range of rotation. Go ahead, rotate your arm at the shoulder. That's a ball-and-socket joint in action, right there.
Next, we've got pivotal joints. In this case, one bone kind of taps into another, creating a pivot point. Now, this doesn't give you a full 360-degree rotation, but it's perfect for that sideways and back-and-forth motion. Just think about shaking your head no or nodding yes. That's your next pivotal joint doing its thing.
This one's super easy to picture. A hinge joint works, well, exactly like a door hinge. It only allows for movement in one direction, back and forth, open and close. Your knee and your elbow are the classic examples of this beautifully simple and effective design.
Okay, I want you to do something for me. Take a moment and just look at your thumb. Wiggle it around. Notice how it can move in all these ways your other fingers just can't? And that's because it has a very, very special joint that is, I'm not kidding, basically a human superpower. This superpower comes from something called the saddle joint. It gets its name from its really unique shape, where 2 saddle-like bones fit right into each other, and that's what unlocks this whole special range of motion. The key here is that it's biaxial. That's just a fancy way of saying it can move in 2 different directions all on its own, back and forth and side to side.
And get this, the thumb is the only place in your entire body you will find a saddle joint. It's what gives us our amazing opposable thumbs.
Now, similar to the saddle joint, the condyloid joint also lets you move along two different axes. So it allows for up and down and side-to-side motions, but it doesn't have quite the same rotation. You can find this joint at the base of your index finger and in your wrist, letting you wave or point with all that precision.
And finally, we have the gliding joint. Just imagine two smooth, flat surfaces sliding right past each other, almost like two panes of glass. This allows for these really smooth, multi-directional movements without any friction. Your ankle and your wrist are just full of these little gliding joints.
So let's just pull back for a second and look at the whole picture. We've gone on this incredible journey, from the fused, immovable plates of the skull to the slightly flexible cartilage in our spine, all the way to the 6 different kinds of synovial joints that give us our awesome freedom of motion. And that is the true genius of our body's design. It's not about just picking one type of joint. It's about the combination, using those rigid fibrous joints for protection in the skull and these super flexible synovial joints for motion in our limbs. It's this perfectly engineered system that strikes a beautiful balance between stability and freedom.
So as we wrap this up, I want to leave you with a final thought. This whole complex system of joints grants us the freedom to live and interact with the world in a million different ways. So the big question we should all be asking ourselves is, what are we doing to protect that freedom?